So for this question, we're told that Alex travels on a bus to get to school each morning, and this is the graph basically of the journey. So the graph is in 5 stages: A, B, C, D, and E. And we can see that time here is on the bottom, and time should always be going across generally. That's kind of how we always keep it, to just always have these things working the same way. And then distance is going to be over here on the left. So we can see that distance increases sort of up the way, and then time increases across the way. And for part A, we're told that during stage B, the bus stopped. And so if we look up at stage B here, we can see that actually stage B has a completely flat line. So in other words, time was still obviously progressing, because it's hard to stop time, but distance stopped moving. So there was no upward movement here for stage B. And we're basically asked in A part 1 for how many minutes was the bus stopped during stage B. And to do this, we basically just find out where stage B started, and it started here. So I'm just going to draw on the diagram now, so we can draw a line down from where it started and from where it ends onto the kind of the axis with time, which is on the bottom. And we just need to subtract the two. So we can see that stage B started at minute 3 and ended at minute 5. And so the answer is just going to be 5 minus 3. And so the answer here is 2 minutes. So that's for part 1. For part 2, we're asked during which stage other than stage B was the bus stopped. And so this is kind of a test of, can you spot where something like stage B happens again? So in other words, we're kind of looking for a flat line here, because we want a place where time was still going, but distance did not increase. And so this is kind of good practice on even just rates of change and understanding these things with time and distance. And we can see here that the time that happened was with stage D. So stage D is also a flat line, and we don't actually have to figure out how long stage D is. We just need to answer that for part 2 that it was stage D. So we just put D in this box. And for part B, we're told that the bus is moving its fastest at stage A. And then we're asked, how do we know this? Just by looking at the graph. So if we look back at our graph here, essentially what we're trying to figure out is, what makes stage A the fastest? And the fastest is always going to be the highest speed. And speed is the same thing as distance over time. So speed is the amount of distance you cover over a certain time. And so we're going to basically be applying that to this question. And we can see here that for stage A, the line increases quite a bit. So it goes up, it's fairly steep, it's like a hill. And basically the steeper this is, the faster the bus would be going. So imagine if instead of what we had here, stage A was like this, and then it came to a stop, that would be a very, very fast moving bus. And it would probably be way too fast to be realistic, but that's kind of just an example of how this would be moving even faster. And then if the line looked like this, in this other red line down here, then that would be a much slower bus, because it would be taking more time to cover the same kind of distance overall. And so for part B, they're not looking for anything too complicated. They just want to see that you can understand that the steeper the line is on our graph, the faster the bus is moving, because the distance increases, whereas the time isn't increasing as much for that distance. And so we can put something to this effect. And so I've just said here, the speed, which is the same as the distance over time, is more in stage A, and the slope is steeper. So they probably want some reference to the slope being steeper here, because we are asked to do it based on the graph. But once you understand that, you should be fine here for part B. And that is going to be it for this question.